Hi, I'm Wally from Blackdot Energy and welcome to the WITS David Webster technical maintenance video. The intent is to really do a very detailed technical and maintenance overview of the system as a first level of inspection if something goes wrong with the plant room or in fact a hot water supply. The reason why we're doing these videos is to really ensure service delivery. Service delivery for WITS to the students is really key and has a very high priority, and that's why these videos will enable a very quick and fast response either from the WITS PIMD maintenance staff or from external contractors. This first video is all about the initial assessment of the plant room, and we call it the kick the tire test. So when you come into the plant room and there's a complaint of no hot water in the building, what are the basic checks? Like before you go on a holiday, you walk around your car, you kick the tires, you check the flicker lights. What are these essential checks that we do? In essence, it comprises of the following. The first section is going to be the visual checks on the tank that I'll explain to you just now. Secondly, we're going to be looking at the burners. And then thirdly, in terms of the ring main circulation and whether there's hot water in fact being circulated into the building. So the first main point of when you come into the plant room to assess whether there's hot water or not is the first step is the pressure and the temperature. So on the side of the tank we have a pressure gauge, and this pressure should be 3 bar. The reason why it's 3 bar is on the opposite side of this plant room we have the cold water plant room, which is also 2 5,000 litre tanks, but is a pressure pump that regulates the pressure into the building. So if that gauge gives you 3 bar, you know that we've got enough pressure in the building and that the cold water plant is functional. If it's below 3 bar, in fact around about 1 or 1.2 bar, you know that we are back on municipal pressure, and that could be a problem. In one of the later videos, we'll then assess what to do in terms of the cold water plant room. The next thing to look at, so let's assume that we have seen that it's 3 bar and we know that the problem is not on a cold water supply. We look at temperature. So the temperature gauge will then show you what is the temperature of this tank at this current point. That temperature should be 60 degrees. And if you look at the position of that thermostat, it is in fact the top third of the tank, and that level of water should always be at 60 degrees. The design in this tank is in fact in such a way that the gas burners does the heating of the top third of the tank, and then the solar does the bottom 2/3 of the tank. Because if the gas runs continuously and heats the entire tank, we have no volume available to introduce the solar energy. So those are our first 2 checks is temperature and pressure. The next thing we're going to be looking at is in fact our gas controller. So this gas controller is a thermostat. The thermostat is set halfway down the tank, and the thermostat is currently, I've switched it off, it's set at 40 degrees. The thermostat at any given point should be set at about 60 or 65 degrees. So what will happen is the thermostat will measure the temperature, and if the temperature at this point is below that set point, it will activate the pump, which will circulate water to the burners will switch on and it will heat the tank. And the burner switches off, switch it on again, and the pump switches on and it heats the water. I'm just switching that off now for the sound for the video. So in fact the third step is to see, is the thermostat set at the right temperature? So if we have the tank temperature at 40 degrees and the thermostat is set at 60 degrees and the pump is not running, that is our next point of identifying the problem. Then the problem is with the tank, with the pump, and the circulation of that water to our gas burners. So that's our third check, is the thermostat set at 60 or 65? And if this tank temperature is below the thermostat temperature, you should hear audibly that the pump which circulates the water through the gas burners is in fact burning or is circulating. The fourth check that we do is the gas burners. And for that, we're going to show you behind the tanks that if these burners show you that the burners are on and it's circulating at temperature, you know that everything is fine. Or if it gives an error code, that's why we have cold water, is in fact because the burners aren't heating. Let's show you the burners quickly. So for the gas burners, the first thing that we need to check is there a display on the Renewable gas burners? So these gas burners have got the capacity to in fact heat this entire tank within 2 hours. So if there's cold water, this is the first point of our problem. You'll see that the first check is if there's a display. If there's no display, number one check is the thermostat, is it set at the right temperature? So in other words, 60 or 65. Then if there's no power here, check the main DB board in the plant room. So the main DB board, you basically just open up the DB board and check that all the circuit breakers are switched on. If there is power on the DB board and we know that we've got power to the units, then in fact check the 3-point plugs that's plugged in at the bottom of the wall, which is just a normal 3-point plug socket. So if we've got no power that's stripped, the 3-point plugs are plugged in and there's no display, there's a problem with the circulation pump. In the second video that we're going to be doing, we'll go in a lot more detail with the gas heating, but remember this is our kick the tire test, just to assess where the problem is and that we know which contractor to get out. So that's in essence the gas burners and the checks that we need to do for that. Next, what I want to show you is in fact the emergency shutdown procedure. If something goes wrong, where's the valves that we shut this plant down with? So let's look at how to shut down and discontinue any flow into the building if something major goes wrong. Because that's crucial to say if something has gone wrong where we've got a pipe that burst in the building or that we've got the tank leaking, and as a contractor or from maintenance PIMD side, you need to shut down the system. Where does that happen? So number one, we have the main municipal valve that brings cold water into the plant room. Secondly, we've got our ring main system. So there's 2 ring main circles that goes into the building, circulation loops, and for that we've got 3 valves. The one that returns at the back of the tank, and then the 2 main ring main lines that goes into the buildings. And I'll show you where those valves are. But those are mainly the key shut-off points, is the incoming cold water. In this hot water plant is the cold water coming into the tank, the ring main return from the buildings, and then the ring main supply into the buildings. So those 4 valves shut off the entire hot water system and will immediately stop any water leaks if there's really an emergency with water valves. So let me start by showing you the main cut-off valve at the back. So the main isolating valve on the cold water is this valve coming into the plant room, and that's from the opposite plant room where we've got the cold water supply. And to shut it down, it's basically this valve that you just push in a closed position. Then for the ring main, we have 3 valves. It's the main return line from the ring main return, which is this single valve at the back, and that valve you then close and isolate. And then we have the 2 ring main valves going into the buildings. One in the hot water plant room and the other one in the cold water plant room that needs to be isolated. And that is basically the conclusion of this video, which is our kick the tire initial assessment of the plant room. The next videos is the more detailed videos on all the other components of this plant room, and we trust that this has been insightful.